thermoforming, and I'm not sure exactly what chapter it is in the book it is, but it's in there. Thermoforming is a process of heating plastic sheet stock and pneumatically forming the thermoplastic material to a mold. Does everybody know what pneumatic means? Remember last year I asked the question and used the term pneumatic, and several people didn't know how to answer because they didn't know what pneumatic means. Anybody not know what pneumatic means? It means air pressure. We form it using air, either compressed air or a vacuum. Our particular machine uses a vacuum. Vacuum is probably the most common, but also compressed air machines are used. What we do is we take a sheet material, like so, and form it around a mold. Like that. And the sheet takes the shape of the mold. So the mold is usually cooled and the shape of the mold is transferred to the plastic sheet. Now in our lab when we do it, we don't run very long. It's just pretty short-term stuff. Our molds are generally made out of plaster or wood and they're not cooled. But in industry, if you're running continuously, you need to have the molds cooled, although they'll get too hot and it'll affect the properties. Thermoforming really isn't a very old process. It was first done for aircraft canopies and relief maps during World War II. You know, you see these old movies from World War II, and they're all looking over this map with the little mountains and stuff on it, and they got their little guys on there and little tanks and you know, all that kind of stuff. Types of parts that are formed: large signs, see gas signs or big gas station signs or big fast food signs, big Burger King sign. Those are made generally on a thermoforming process. Basically anything that you can make using a sheet material. Those signs generally will be made in two parts and then they're stuck together. Light fixtures, housings for different product, cases, a lot of cases that are used for carrying things that you buy, say a little case for tools, cases for like a socket set. Cases, a lot of cases that are used for carrying things that you buy, say a little case for tools, cases for like a socket set, things like that, made on a thermoforming process. Refrigerator door housings, mentions packaging. Packaging is probably the largest part of the business as far as thermoforming goes. Think of all the packaging we buy, plastic packaging. Much of it is thermoform. Think of tubs like for margarine and cottage cheese, those kind of things. Egg cartons. Blister and skins packaging, where you have a product that has on the back of it a cardboard sheet, say, and then there's plastic over the top of it that holds it together. Usually small parts are packaged that way. When you use a film to package, in a lot of cases, we use a thermoforming process. Another example of packaging, Kerwood, which is here in town, they make 90+% of all the Oscar Mayer Lunchables that are made and sold in this country. So if you ever had a Oscar Mayer Lunchable, the packaging is made at Kerwood. But they also make the little individual servings for coffee creamers, those kind of things. A lot of small type individual food application parts. One thing was kind of interesting when we would go to Kerwood. We would usually go to Kerwood and Stylecrest the same day because they're right in the same area in Fremont here. Kerwood is very, very clean. They make food packaging, so the floor is spotless. You can eat off the floor just about. And when you go in there, you have to wear hairnet. They make you wear a beard net too, because you can't get hair into the products. It's very clean. And then you go to Stylecrest, which we will go to, and they use powdered resin, and they do a lot of grinding of recycled PVC parts, and there's dust and stuff everywhere. It's really dirty. It's really a kind of a difference in the two different places. But the main reason is because they have to deal with this food packaging, and there's lots and lots of regulations that go along with food packaging. Talk about molds a little bit. In industry, they're usually made out of aluminum, cooled by chilled water. Here's an example of an aluminum mold here. It's fairly big. You can see the surface of it. This is a holly leaf, actually. It'd be made for maybe a jello mold or something like that. If you look in the back, you can see that there's some lines here that are water lines that you can hook up to your chilled water system to keep this mold cool. Most molds that you see in industry have cooling in them some way or another. There's also, you can see on there, you have little holes in here that helps the air go through it so it sucks the plastic down around it. This would be an example of a female mold where the cavity goes down inside. And this is a male mold where the part sticks up. Female mold is better for multi-cavity forming. We'll see why that is in a second here. It's less easily damaged, so that, if it's the part that is important that touches the plastic is kind of recessed, so it's a little bit more protected than this one where it's more exposed. It's less easily damaged. The male molds are easier to make and less expensive because it's a little tougher to machine down into the cavity than it is something like that. The disadvantage of the male mold is that if you're making multiple parts, they must be spaced at least as far apart as their height. You have to spread them out more. Using a female mold, you can get more parts out of a single sheet than you could with a male mold. So when you're making multiple parts, it'd be easier to use female mold. Here's another example of a finished part that is thermoformed. You can think of lots of different packaging items that are made thermoform. Here's a couple other molds. Here's one that is made in our lab. It says Velvet's Shining Shamrock. One of the things you do in the thermoforming class is that you have to make your own molds. So you have a project. This one was a sign over the stall of one of the students' horses. When you get into that class, you'll get to make a mold. Here is one of the more popular types of projects. We have just tons of these candy molds. This one happens to be Halloween, which is coming up here soon. So if anybody's interested in making, chocolate candies, like for Christmas or any holiday you can possibly think of, we probably have candy molds to make that. You just heat up the chocolate, you pour it into the mold, and you get your candy. See? You guys are creative that way to make candy. We got lots of those there. There's some terms that are important in thermoforming. One of them is the draw ratio, and that's the maximum cavity depth divided by the minimum span across the opening. The deeper you draw down in a female mold, the more difficult it is to make it. And this is just gives you an idea of the ratio between how deep it is versus how wide the opening is on top. The greater the draw ratio, the more difficult it is to make this kind of part using conventional vacuum forming, what we have in the simplest type process. Mark-off is a term that's used to refer to marks left on the finished product of the mold if it's damaged or has some dirt on it. Now, one thing about plastics and molds, the plastic pretty faithfully reproduces the surface of the mold, which is good when you start off and you have the right surface on there. A slit in it or a cut in it or mark it up, that's also going to show up on your parts. That's why we always say when you work around molds, make sure you use brass tools because they won't mark them up as easily as steel tools will. Draft angle is the angle of the side of the mold. If we looked at the side of this mold, for instance,